talks about other four-sided shapes that are specific instances of parallelograms. You have probably heard of all of these. So the next one that we're going to look at is a rectangle. A rectangle, which, because it's a specific type of parallelogram, it has all of these properties, right? So a rectangle still has the opposite sides parallel to each other. It still has that the opposite sides are equal in length. It still has that the opposite angles are congruent. It still has that the consecutive angles are supplementary. It still has that the diagonals bisect each other. All that stuff is true. But a rectangle has extra stuff. With a rectangle, you also have every angle is 90 degrees. And you also have that the diagonals are congruent. So rectangles are parallelograms. They have everything that's true of a parallelogram, but they have some extra stuff. Okay? Next, we have a square. A square is another specific type of parallelogram. It is also a specific type of rectangle. So a square is kind of like saying, I was born and raised in Oregon, so I'm an Oregonian. As an Oregonian, I am also somebody who was born and raised in the United States. Does that make sense? So I'm also somebody from the United States. I was also born and raised in North America. Does that make sense? So parallelogram is like saying North America, I'm from the continent of North America, but I'm from the country of rectangle, but I'm from the state of square. Make sense? So you can have something where it's like just more specific examples of that. So the state is the really specific example. The country is the less specific. The continent is the even less specific. It's the even more general. So a square is a specific example of a rectangle, which is a specific example of a parallelogram. Does that make sense? Okay. So a square has all the same properties of the parallelograms and rectangles. So a square also has 90-degree angles, also has sides that are congruent, but it also has all four sides are equal in length. And the diagonals bisect the opposite angles. They cut the opposite angles in half. And the diagonals are perpendicular to each other. What does it mean if diagonals are perpendicular to each other? They cut through each other and they make what kind of angle? A 90-degree angle. So those diagonals, they cut each other in half and they make a 90-degree angle while they do it. And while they're making that 90-degree angle, they're cutting into the corners of the square and they're making those corners cut in half as well. So a square has 90-degree corners and they're cutting those corners and they're making them cut into 45 degrees. 45, 45. All right. A rhombus is a specific type of parallelogram. It has all the same properties of parallelograms, and all of the sides are equal in length. The diagonals bisect the opposite angles, and the diagonals are perpendicular to each other. I didn't type this, but a square is a specific type of rhombus. So in my head, I always think of a rhombus as a square that's been slanted, like you took a square and you knocked it over, but it didn't like fall down, like But really, it's just saying that a square is a rhombus that's been like pushed upright, basically. Okay. Have we seen all those shapes before? Yeah? Okay. Go ahead and flip your notes over, because I thought that this was a complete list, and then the longer the EOC has continued on, I have learned it's not a complete list. So they don't just test you on four-sided shapes that are parallelograms, because that's what we just went over, is four-sided shapes that are parallelograms. There are some other four-sided shapes they also might test you on. So we're going to say other quadrilaterals. Quadrilateral. Other quadrilaterals. Trapezoids. We're going to have two types of trapezoids on our list. We're going to have just a regular trapezoid, and then we're going to have something called an isosceles trapezoid. Before we get into an isosceles trapezoid, can somebody remind me what an isosceles triangle is? Two sides are the same, okay? So an isosceles trapezoid is a trapezoid where two sides are the same. Okay, so I am going to draw that in a second, but it's not going to be the first trapezoid that I draw. Okay? All right, so the first trapezoid that I draw is going to be a trapezoid where the two sides are not the same. So this trapezoid is not maybe going to be the typical one that you see. So I'm going to draw it like this. I'm going to draw it with kind of a 90-degree angle. So a trapezoid is a shape, it's four-sided, where the top and the bottom are parallel. A trapezoid has, and I didn't draw them very parallel, but you get the idea. A trapezoid has one pair of parallel sides. One pair of parallel sides. That's what a trapezoid is. And when we label a trapezoid, we would call this the height. That makes sense. And what's kind of weird about a trapezoid is they call this base 1 and this base 2. And they say that the area of a trapezoid, and you are going to need to know this because it does show up, the area of a trapezoid is 1/2 of the height multiplied by base 1 plus base 2. Somebody want to answer that and say, you can say Miss Rice or Miss King, you get to choose. Say it's my room and then say student speaking. All right, this right here, right down the middle, is called the median. It's just the middle. And the median is 1/2 of base 1 plus base 2. Which makes sense, right? Just find the average of them. So add them together, divide it in half. Okay, so that's just any old regular trapezoid. The two sides to the left and right, it doesn't matter what slant they have. They could be straight up and down. They could be slanty, as long as two of the sides are parallel to each other. Okay, now we're going to draw an isosceles trapezoid. This is the one that, like, when you were a little kid, you might have had blocks that looked like these. So there's the pair of parallel sides, and then these two sides are the ones that are the same length. So we've got parallel, parallel, and then we've got like, oh, these are the same length. That's the isosceles part of it. Now, with an isosceles trapezoid, what ends up happening is that because these two are the same length, it makes it so these two angles are exactly the same measure, and these two angles are exactly the same measure. And then this angle and this angle right here, these consecutive angles, those are supplementary. And I'm not going to draw it in the picture because the picture is going to get really complicated, but the diagonals are also congruent. Both of them, right? So this diagonal right here is congruent to this one right here. I guess saying both of them are congruent is redundant. One diagonal wouldn't be congruent to anything. Okay, so that's an isosceles trapezoid. Any questions about the trapezoid? Does it make sense? Okay, we've seen all these shapes before. Nothing crazy about that? Okay, the next one, which is a shape, it's also a toy, but it is a shape. The next one is a kite. This is a real shape. It is easiest to draw if you make a T first. That is my opinion. So here is my kite. I feel like that was decent. Yes. So these two sides are the same length, and these two sides are the same length. These two lines are considered to be the diagonals. You can write a note to yourself if you need to that these two lines are the diagonals. And the diagonals do come together at 90-degree angles. So I'm drawing this in the middle. I'm not saying there's a box in the middle. I'm saying that each of these is a 90-degree angle. All right. This whole angle is the same as this entire angle. This long diagonal right here, it cuts these two pieces in half. It cuts these in half. So we're going to say that this angle right here is the same as this angle right here. And this angle right here is the same as this one right here. A special note, this diagonal right here, it does not cut these in half. You can even see it in the picture, right? This one's a little bit smaller than that one. So this whole angle is the same as that whole angle, but it does not, they're not cut in half, okay? If you can't tell that from the markings on the picture, you should write yourself a note, okay? This long diagonal cuts this short one, it cuts it in half. So this half and this half are the same. I think that's all the markings. Okay. Are there any markings I need to describe again so that you can write a note to yourself? Nope. We're good? We got it? Okay. So what we're going to do with the rest of the period is we're going to look at... Oh, Jasmine, you're back. We're going to look at Google Classroom. And if you look on Google Classroom, there is a parallelogram. It's a station activity, only I didn't put them up around the room because I know sometimes we just like to sit in our chairs. Is that okay to sit in our chairs for today? Yes, okay. So you're going to start at station 1, and it says quadrilateral EFGH. Okay, so remind me if it says EFGH, what do we have to be careful of when we draw it? Yeah, we make sure we don't go left to right. We start at 1, go clockwise. Okay. Doesn't matter where you start. Nope, doesn't matter where you start. Okay, so I'm going to start at station 1. And it said quadrilateral EFGH is a rectangle, so I can go ahead and draw a rectangle and just make it look like that. And technically, you don't even have to go clockwise. You could go counterclockwise. All that matters is that you go in a circle. That's all that matters. As long as you don't go left to right, you're good. So I'm going to start in the upper left corner because that's what I typically do. So EFGH. EFGH. Okay. So number one says rectangle EFGH. Diagonals that intersect at M. So I'm going to draw the diagonals. And they're going to intersect at M. So these diagonals intersect at M, okay? It says the length of E to M is 5x plus 1. E to M is 5x plus 1, okay? And it says H to F, this whole length, I'm going to use a color so that I can tell it's the whole length. H to F is 42. Okay. Find the value of X and the length of EM. Okay. So if we have a rectangle, I'm going to grab my notes about rectangles. What do we know about the diagonals of rectangles? They're congruent. The two diagonals are going to be the exact same length, okay? The diagonals are congruent, okay? What else do we know about diagonals? Because a rectangle is still a parallelogram. They bisect each other. Okay, so they cut each other in half. They are also both the same length. So I know that if this entire diagonal is 42, then what do I know about this entire diagonal? It's also 42. If this half is 5x plus 1, what's this half? 5x plus 1 as well. I'm going to go ahead and label it 5x plus 1. Okay, so 5x plus 1, 5x plus 1, and what are both of these together going to add up to? 42. So I'm going to say 5x plus 1, 5x plus 1 equals 42, and I use the properties to figure that out. Does that make sense? Okay. When you're done, you're going to do what the instructions say. The instructions are telling us not only to find the value of X, but also to take that X and plug it back in and find the length of EM. And then from there, it'll tell you what station to go to. And that's just whatever, if it was around the room, it would feel like stations, but it's just telling you what card to go to next. And then you go to the next card. If you are doing them, if you get the answer wrong, you're going to find yourself going to cards that you've already been to. Okay, and that's how you'll know that you're getting the answers wrong. Any questions? We're good? You'll know that you're done because you'll get back to 1, and you'll have done, how many? You'll have done 12 problems. This is supposed to be a worksheet that I should have printed for you, but I didn't, so you're doing it on notebook paper, not this. So there are 12 problems total. Okay, this is what we're doing for the remainder of the period. So what you have to turn in by Monday is the rest of the parallelogram worksheet and this activity. Okay? All right. Cool. You guys are all set.